Imagine spending years searching for the secret to eternal life, only to discover something that would transform war instead. Around the 9th century, Taoist alchemists in China devoted themselves to an extraordinary goal. They believed nature concealed an elixir capable of extending life forever. Their laboratories became places of endless experimentation, where minerals, herbs, and strange powders were mixed together in countless combinations, each one offering another hope of defeating death. For a moment, the workshop fell silent. No warning, no sign, just stillness in the air as the alchemists paused over their work. Then, a sudden ignition, a flash of light, a violent burst. The room breaking into chaos in an instant. Instead of a life-giving potion, the mixture erupted into fire. Historical accounts describe burned hands, scorched beards, and workshops damaged by sudden explosions. The people responsible weren't inventors of weapons. They were scholars chasing immortality, yet they had accidentally uncovered one of the most influential chemical discoveries in human history. The substance became known as huoyao, or fire medicine. The name itself reveals its forgotten origin. It wasn't created for armies. It wasn't designed to conquer kingdoms. It began as a failed medical experiment. Yet history has a strange habit of turning accidents into revolutions. Over time, this mysterious powder began to appear in new places, handled by new hands, tested in ways its original creators could never have imagined. Its behavior was unpredictable, its potential still unclear, but one thing was certain: it refused to be ignored. And slowly, question by question, experiment by experiment, people began to realize it was not just a curiosity, it was a force waiting to be understood. But none of that happened overnight. Between that first accidental explosion and the invention of the gun lay hundreds of years of careful observation, experimentation, and gradual improvement. Every generation solved one problem, leaving the next generation to solve another. The journey from laboratory curiosity to battlefield weapon is far more fascinating than most people imagine. Because before anyone learned how to fire a bullet, they first had to understand why this strange black powder exploded at all, and that simple question would unlock the science behind one of history's greatest inventions. At first glance, gunpowder doesn't look remarkable. It's just a dark mixture of ordinary-looking powders. Yet hidden inside those simple ingredients is enough energy to reshape civilizations. The original formula relied on 3 key components: saltpeter, charcoal, and sulfur. Each ingredient served a different purpose. Saltpeter, known today as potassium nitrate, acted as an oxidizer. Instead of burning itself, it supplied oxygen at incredible speed, allowing the reaction to continue even inside a tightly packed container, where ordinary fire would quickly suffocate. Charcoal became the fuel. Sulfur lowered the ignition temperature and helped the entire mixture burn faster and more consistently. Separately, none of these materials were extraordinary. Together, they created something entirely new. The moment a spark reached the powder, the reaction began almost instantly. The solid ingredients broke down in an instant, releasing a surge of hot gas. With nowhere to escape, that gas built up faster and faster until pressure had no choice but to explode outward. That sudden expansion is what would later drive cannonballs, bullets, and rockets across battlefields. In other words, the secret wasn't the fire, it was the expanding gas. Without that sudden burst of pressure, a firearm is nothing more than an empty metal tube. Ironically, the first people to discover this reaction had no intention of building weapons. For many years, fire medicine remained a curiosity. It appeared during religious ceremonies, public festivals, and celebrations where colorful flames, loud bangs, and clouds of smoke amazed crowds. To ordinary people, it was entertainment rather than something to fear. No one could have imagined that the same powder lighting the night sky would one day decide the fate of kingdoms. But military leaders saw something different. They didn't just notice the noise. They noticed the force behind it, and once they realized that force could be controlled, gunpowder's future changed forever. The next invention was surprisingly simple: a bamboo tube attached to the end of a spear. Yet that humble device would become the world's very first true gun. For decades, gunpowder remained a spectacle. It dazzled crowds during festivals, it echoed through religious ceremonies, it painted the night sky with flashes of light and clouds of smoke. But eventually, someone asked a different question. What if this explosive force could do more than entertain? During the Song dynasty, Chinese military engineers began experimenting with practical ways to use gunpowder on the battlefield. They weren't trying to invent a gun, not yet. Their goal was much simpler: create a weapon that could frighten, burn, and disrupt an enemy during close combat. The solution looked surprisingly primitive. A hollow bamboo tube was tightly fastened to the shaft of a spear. Inside the tube, they packed gunpowder. When ignited, the weapon blasted a stream of flames, sparks, hot gases, and burning fragments toward anyone standing only a few feet away. It became known as the fire lance. By modern standards, it wasn't very accurate. It couldn't fire bullets, and its range was extremely limited. But for soldiers who had spent their lives fighting with swords, spears, and bows, seeing an opponent suddenly unleash fire from the end of a weapon must have seemed almost supernatural. Its greatest strength wasn't always the damage it caused. It was the fear it created. Historical records describe fire lances in action during 12th century sieges. Picture a narrow city gate under assault. Attackers press forward, climbing ladders against the walls, pushing through the choke points of the entrance. Above them, defenders brace the bamboo tubes along the battlements. A spark is struck. For a split second, nothing happens. Then the weapon erupts. A violent burst of flame and smoke surges outward, filling the confined space. The front ranks of the assault are engulfed in heat and confusion. Ladders shake. Soldiers recoil. The formation below collapses into disorder as fire and panic spread faster than any blade could move in those tight spaces. Even a brief ignition could decide the outcome of an entire assault. Yet military engineers quickly noticed something even more interesting. Sometimes, small stones, bits of metal, or broken pottery packed inside the bamboo tube were blasted outward by the explosion. Those fragments traveled farther than the flames themselves. And for the first time, people realized that expanding gas could launch a solid object with tremendous force. That single observation changed everything, because the next challenge wasn't making a bigger flame. It was building a stronger tube that could survive a much more powerful explosion. The fire lance had proven one important idea. Explosive gas could launch an object, but it also revealed a dangerous problem. Bamboo wasn't built to contain pressure. As engineers experimented with stronger gunpowder mixtures, the tubes often cracked, burst apart, or even exploded in the hands of the soldiers using them. The weapon had reached the limits of what nature could provide. If gunpowder was going to become more powerful, the weapon itself had to evolve. Chinese metalworkers already possessed centuries of experience casting bronze for bells, tools, and ceremonial objects. Eventually, someone realized that the same techniques could produce something far stronger than bamboo. The result was a thick metal tube capable of surviving repeated explosions. It was a simple invention, but it changed history. Instead of releasing only fire and sparks, these new weapons could launch a single stone or iron ball using the rapidly expanding gases created by burning gunpowder. The world's first hand cannon had arrived. Unlike the fire lance, the projectile no longer depended on flames to injure an enemy. The projectile itself became the weapon. This marked a completely new way of thinking about warfare. Power no longer came from the length of a spear or the strength of the soldier holding it. It came from controlled pressure trapped inside a metal barrel. By the 13th century, hand cannons were appearing across China, and engineers began scaling the same idea into heavier siege weapons designed to strike fortified walls that had once seemed nearly impossible to breach. Although these early firearms were slow, heavy, and often inaccurate, they proved something undeniable. Gunpowder could do far more than create noise and fire. It could launch deadly force over distance. That realization spread quickly, and it wouldn't remain inside China for long. A rapidly expanding empire was about to carry this remarkable technology across thousands of miles, introducing the rest of the world to a discovery that would change warfare forever. By the early 1200s, gunpowder weapons were no longer a curiosity confined to China. They had become practical tools of war, and then history introduced the perfect messenger, the Mongol Empire. As Mongol armies swept across Asia, they encountered Chinese cities defended by hand cannons, explosive bombs, and other gunpowder weapons. Rather than ignoring these unfamiliar inventions, the Mongols did something they often did with useful technology. They adopted it. Skilled Chinese engineers and craftsmen were brought into Mongol service, where their knowledge became just as valuable as their weapons. Siege equipment improved, explosives became more sophisticated, every successful campaign exposed new regions to technologies they had never seen before. Without intending to, the Mongols became history's greatest carriers of military innovation. As their empire stretched from East Asia to the edges of Europe, ideas traveled alongside soldiers, merchants, and diplomats. Gunpowder no longer belonged to a single civilization. It had begun a journey across an entire continent. But firearms weren't the only inventions making that trip. Rocket-powered arrows, incendiary bombs, and explosive projectiles also spread along these growing networks. Some of these early devices would fade away over time, while others would evolve into more refined battlefield weapons used in later centuries. By the late 13th and early 14th centuries, knowledge of gunpowder had reached the Islamic world and was steadily moving toward Europe through warfare, trade, and cultural exchange. Along the same routes traveled paper, the magnetic compass, and printing, Chinese innovations that quietly reshaped civilizations far beyond their place of origin. Soon, European blacksmiths and military engineers would begin adapting this mysterious invention to solve their own battlefield problems. And once they did, The age of castles, armored knights, and medieval warfare would never be the same again. By the time gunpowder reached Europe, it wasn't a finished invention. It was an idea waiting to be improved. The earliest European firearms looked crude by modern standards. They were little more than small metal tubes fixed to wooden poles. A soldier poured black powder down the barrel, added a stone or iron ball, then touched a glowing match to a tiny opening at the rear. Sometimes the weapon fired, sometimes it misfired, and sometimes it failed completely. Despite their flaws, they introduced something medieval warfare had never faced before: a weapon powered by chemistry instead of muscle. For centuries, armies had measured strength in familiar ways: a thicker shield, a sharper sword, a stronger bow, heavier armor. Gunpowder ignored all of them. A well-placed cannonball could smash through defensive walls that had protected castles for generations. Thick stone fortifications, once symbols of security, suddenly became vulnerable to repeated bombardment. Even heavily armored knights, the elite warriors of medieval Europe, began losing the advantage they had enjoyed for centuries. Expensive suits of steel could no longer guarantee survival against a fast-moving projectile driven by explosive force. This wasn't simply a new weapon, it was a new balance of power. Kings gradually realized that disciplined groups of ordinary soldiers armed with firearms could challenge mounted nobles who had spent their entire lives training for combat. And that realization didn't stay theoretical for long. On the battlefield, it began to reshape how wars were actually fought, line by line, formation by formation, until the old reliance on individual knightly skill started to fade. The effects reached far beyond the battlefield. Military architects redesigned forts with lower, thicker walls that could absorb cannon fire instead of resisting arrows. Political power slowly shifted towards centralized kingdoms capable of producing cannons, gunpowder, and trained infantry on a large scale. But early firearms still suffered from one frustrating weakness: firing them required perfect timing. One hand held the weapon, the other carried a burning match. Trying to aim while manually igniting the powder was slow, awkward, and dangerously unreliable. Engineers knew there had to be a better solution. The answer would arrive in the form of one remarkably simple mechanical invention: a trigger that finally allowed the gun to fire itself. For centuries, the greatest weakness of early firearms wasn't their power. It was their ignition. Every shot demanded patience, coordination, and a little luck. A soldier had to balance the weapon, keep a burning match alive, and lower that flame onto the powder at exactly the right moment, in the confusion of battle. That was far easier said than done. Rain could extinguish the flame. Wind could blow it away. A single mistake could leave a soldier defenseless while trying to reload. Military engineers knew that gunpowder wasn't the problem. The problem was lighting it. Sometime during the late 15th century, they introduced a remarkably clever solution. Instead of holding the burning cord by hand, the weapon would hold it itself. This became known as the matchlock. A curved metal arm gripped a slow-burning fuse above the gun. When the shooter squeezed a trigger, that arm pivoted downward, touching the glowing match to a small pan of priming powder. In an instant, sparks flashed into the barrel, igniting the main charge without the soldier ever taking a hand off the weapon. It sounds like a small mechanical improvement. In reality, it changed warfare. For the first time, soldiers could keep both hands on the firearm while aiming. Accuracy improved. Training became easier. Entire groups of infantry could now fire in organized formations rather than as scattered individuals. The matchlock spread rapidly across Europe. Before long, it reached the Ottoman Empire, where elite Janissary units incorporated firearms into their military system. Portuguese traders later carried the technology to Japan, where local craftsmen refined the design with extraordinary precision. Ironically, China, the birthplace of gunpowder, also adopted improved matchlocks that had evolved beyond its own original designs. A discovery that had begun as fire medicine was now circling the world. But the matchlock still carried one stubborn flaw. It always needed a burning fuse, and on a dark, rainy battlefield, that tiny glowing ember could become both a soldier's greatest tool and his greatest weakness. The matchlock was a remarkable invention. But it came with an obvious problem. Every soldier still had to carry a burning fuse. That glowing cord revealed positions at night. Rain could extinguish it. Strong winds could make it unreliable. And if the match went out, the gun became little more than a heavy club. Engineers across Europe searched for a better answer. Their first major breakthrough appeared during the early 16th century. Instead of relying on an open flame, inventors created a mechanism called the wheel lock. Inside the weapon, a tightly wound spring spun a steel wheel against a piece of pyrite, producing a shower of sparks that ignited the powder automatically. For cavalry soldiers, this was revolutionary. A rider could carry a loaded firearm without worrying about protecting a burning fuse while galloping across rough terrain. The system worked, but it came at a price. Wheel locks contained dozens of tiny moving parts. They were difficult to manufacture, expensive to repair, and too costly for most ordinary armies to equip on a large scale. The search continued. Then, in the early 17th century, another invention changed everything: the flintlock. Its design was surprisingly elegant. A small piece of flint struck a hardened steel plate, creating sparks that ignited the priming powder with remarkable consistency. Fewer moving parts meant greater reliability, lower cost, and much easier maintenance. Within a few decades, flintlock muskets spread across Europe and gradually replaced older firing systems. For nearly 200 years, they became the standard firearm of soldiers, explorers, and expanding empires. They reshaped warfare on a global scale. Armies could now project force farther, faster, and with far greater consistency than ever before. Yet despite all these improvements, one battlefield problem still remained. A musket could fire only one shot before it needed to be reloaded. And during those precious seconds, an advancing enemy could reach you with a sword or spear. The solution would seem almost unbelievably simple. Instead of choosing between a gun or a spear, someone decided to combine both into a single weapon. For centuries, European armies relied on teamwork between different kinds of soldiers. Some carried long pikes to stop charging cavalry. Others fired muskets from behind their protection. Neither group could survive very long without the other. Musketeers were powerful at a distance, but painfully slow to reload. Pikemen could defend against swords and horses, but couldn't strike an enemy until they were almost within arm's reach. It was an effective system, but it was also complicated. Then someone had a remarkably simple idea. Instead of protecting the musketeer with another soldier, why not turn the musket itself into a spear? Early inventors attached blades directly into the end of the barrel. These plugged bayonets worked, but created a new problem. The moment the blade was attached, the gun could no longer be fired. Soldiers had to choose between shooting or fighting hand-to-hand. That limitation didn't last long. By the late 17th century, engineers introduced the socket bayonet, a clever design that locked around the outside of the barrel instead of blocking it. Now, everything changed. For the first time, one soldier could replace what had once required two. A single infantryman could fire his musket and then instantly transform it into a spear without losing either capability. The impact was enormous. Entire formations of pikemen slowly disappeared from European armies. Every infantryman now carried both a firearm and a pole weapon in a single piece of equipment. Training became simpler. Armies became more flexible. Commanders no longer had to coordinate multiple specialized units on the battlefield. What had once required carefully balanced formations could now move, fight, and adapt as a single unified force. Even the psychology of war changed. Long before two armies actually collided, the sight of hundreds of soldiers advancing together with fixed bayonets often shattered enemy morale. Many battles were decided before the first blade ever struck its target. Yet despite these remarkable improvements, one frustrating problem still refused to disappear. Every firearm still depended on loose gunpowder, exposed priming powder, and carefully timed sparks. Rain, humidity, or a single mechanical failure could still prevent the weapon from firing. The next invention would finally solve that problem and complete a technological journey that had begun nearly 1,000 years earlier with one accidental explosion in a Chinese alchemist's workshop. By the beginning of the 9th century, firearms had come a long way. The flintlock was reliable, the bayonet had transformed infantry, gunpowder had conquered battlefields across continents, yet every soldier still lived with the same uncertainty. Would the gun fire when it mattered most? A little moisture inside the priming pan, a dull piece of flint, or a poorly timed spark could still turn a weapon into dead weight. Military engineers knew the next breakthrough wouldn't come from a larger barrel or more powerful gunpowder. It would come from a better way to ignite it. That breakthrough arrived with the percussion cap. Instead of relying on exposed powder and flying sparks, the new system used a tiny metal cap filled with a shock-sensitive chemical compound. When struck by the hammer, it exploded instantly, sending a flash directly into the barrel and igniting the main charge. It was a remarkably small invention, but its impact was enormous. Firearms became faster, far more dependable, and much less vulnerable to rain and wind. For the first time, soldiers could trust that pulling the trigger would almost always produce the same result. At nearly the same moment, another revolution was taking place. Factories powered by the Industrial Revolution began producing standardized metal parts with unprecedented precision. Guns no longer had to be handcrafted one at a time by skilled artisans. Components could be manufactured in large numbers and assembled with consistent quality, making repairs easier and production dramatically faster. Within a few decades, each of these innovations began to reshape firearm design in its own way. Repeating rifles allowed multiple shots without reloading. Metallic cartridges replaced loose powder and ball with a single self-contained unit, and industrial manufacturing techniques made it possible to produce weapons at a scale and consistency that had never existed before. The pace of innovation, once measured in centuries, was now measured in decades. The weapon had finally become modern. But perhaps the most remarkable part of this story isn't how quickly guns evolved. It's how unexpectedly that journey began. Because none of it started with soldiers or kings or military engineers. It began with people searching for something completely different. And that accident would leave a mark on human history unlike almost any other discovery ever made. Let's go back to where this story began. A quiet laboratory, a handful of minerals, and a group of Taoist alchemists searching for eternal life. They believed the right formula might defeat death itself. Instead, they discovered a force that would forever change how humans fought each other. History is filled with inventions created on purpose. The wheel, the compass, the telescope. But some of the world's most influential discoveries arrived by accident. Gunpowder is one of them. No one planned the firearm. There was never a single inventor who woke up one morning and designed the modern gun. Instead, it emerged through centuries of small improvements. One generation discovered an explosive mixture. Another trapped its force inside a bamboo tube. The next replaced bamboo with bronze. Then came mechanical triggers, stronger barrels, better ignition systems, and finally, the reliable firearms that transformed the modern world. Each innovation solved one practical problem. Together, they reshaped history. And in that simple pattern lies the entire story of human progress. Empires rose because of gunpowder. Castles that had stood for centuries became obsolete. Armored knights gradually disappeared from battlefields. Even the architecture of cities, the organization of armies, and the balance of global power evolved alongside this remarkable technology. Yet perhaps the most fascinating lesson isn't about weapons at all. It's about human curiosity. Again and again, people searching for one answer accidentally uncovered another. The alchemists wanted immortality. Instead, they revealed a chemical reaction that future generations transformed into one of history's most influential inventions. It reminds us that progress rarely follows a straight line. Sometimes the discoveries that shape civilization aren't the ones people are trying to make. They're the unexpected results of asking questions, testing ideas, making mistakes, and refusing to stop experimenting. So the next time you see a modern firearm, remember that its story didn't begin on a battlefield. It began in a quiet workshop with a failed experiment, a burst of fire, and a tiny accident. That quietly changed the course of civilization.